Hi, I'm Mr. Leong, and in this video, I'm going to be covering topic 1.3, representing a categorical variable with tables. So the learning objectives here are to represent categorical data using both frequency or relative frequency tables, and then to describe data represented in these two types of tables. So this is going to be a very short video. Just going to go through this one example. So suppose that we have surveyed some students and asked them, what is their preferred way of communicating with their friends? And so as we're recording, we're just, doing tally marks when certain students select a certain category. So 2 students chose cell phone, 1 student chose Facebook, 3 said in person, and 4 said text messaging. Okay. So there isn't a whole lot we can do with tally marks. So the first thing we're going to do is we're going to take this tally table and convert it to a frequency table. Okay. Now a frequency table is essentially just turning those tally marks into counts, into actual numbers. And so when you hear the word frequency, just think of the fact that, okay, this is a table of counts. It's telling me how many students have been counted within each category. Now, something that this table is missing, which I'm going to add here at the bottom, is a total, right? It would be nice to have down at the bottom of the table a total so we know how many students are represented in this data set. And so the total there is 10. So aside from just having a table of counts, we might want to create what's called a relative frequency table, which is to see how those counts compare relative to other counts. And so if we were to do that, this is what we would do. We would want to know how those counts compare to each other or how they compare to the whole. So we know there's 2 students who prefer cell phone out of a total of 10 in the group. So that's 0.20 or 20%. Facebook is 10%, in person is 30%, and text messaging is 40%. So when we say relative frequency table, we're talking about table of proportions or percentages, right? They're equivalent things. Okay. Now, in a frequency table, the total is a number, how many students there are. But in the relative frequency table, the total will always be 1, or in terms of percentage, 100%. Okay. So that's true for any relative frequency table. The total will always be 1 or 100%. So when we've summarized or organized categorical data into either a frequency table or a relative frequency table, we can start to look for patterns and make claims. So for instance, we could make a claim that Facebook was the least popular method of communication, right? Or text messaging was the most popular method of communication. Or we can say a vast majority of students prefer to communicate electronically. By electronically, I mean using some sort of digital device, whether it's a phone or a computer, internet, text messaging, right? That would add up to 70%, which is why I said majority. And so it's really the relative frequency table that is probably the more advantageous of the two, just because we can see how categories compare to one another or compare to the whole. And then in the future, when we maybe have data from 2 different groups, maybe teenagers versus adults, right? It's going to be the relative frequency table that we use to make comparisons because they've been scaled to the same total, right? 1 or 100%, right? Whereas if I used a table of counts, that would only make sense if I surveyed the same number of teens and adults, right? If I surveyed 10 teens and 20 adults, now comparing counts is useless because the totals aren't the same. But if I convert into proportions or percentages, now I've scaled so that the total is the same for both groups, which makes the relative frequency table much more useful when it comes to comparing.